All right, I'm extremely sorry. The connection just broke. It just exited, and I'm again back in the session. All right, extremely sorry for that. Are you able to hear me now? Basically it just exited. Okay, so I need to find an alternative to webinar because Google Hangout will not work because Google Hangout needs cannot have more than 10 attendees. All right. Are you able to hear me now? Extremely sorry for this. It just got disconnected. Okay. So I was taking the backup of the recording. All right. Now coming back to what I was talking about. Okay. So there was some questions regarding this. So can you explain 6 and 7? Okay. First, let me try to answer this. So here what we are trying to do is we are saying whatever is this data inside averaged, store it into this file. Okay, look at the single column. It means the name of, it's a string, it means the name of a file. We could give it an absolute folder as well, but we are giving it relative, as in it doesn't start with slash. That means it is going to be stored in your home folder. Okay, and you can see it here that it has been created. All right. Now coming back to what I was talking. So this was a quick script of pig which we have written. Even if you are not able to understand it, don't worry. We will go step by step and try to understand it one step at a time. Okay. Also, we can have a look at what is inside that output file. All right. Now, in the when we ran the previous script, it created a folder called average, just like our MapReduce. When we run MapReduce, it creates the output folder, and inside that output folder you see the success file with the zero size is the same as our MapReduce. Second, you see R here, part 00R. So it's basically generated by MapReduce. So effectively, all I want to convey here is that we did all of this to create a MapReduce program internally. Okay, so when we wrote this script and run it through Pig, it basically created the MapReduce and executed it. Okay, all right. Now, next question is whether Pig can access data directly from database or it can consume data in the form of file. Okay, good question, Anand. It can do both. But generally, we first move the data from non-Hadoop systems to Hadoop system in order to analyze it. All right. Now, so that was I mean, whenever we are learning a language, we generally go back and forth from the example to the code. I mean, we'll step back forward and then step backward, as in we saw a program and then again went to back to the definition. Then we again saw a program. Then we are going back to the definition. All right. So like in any language, you have data types. Here also in Pig, you have data types of the columns. When we load the data, we say that our data is in this form. So the data types in Pig are are basically similar to Java, okay, and somewhere between Java and SQL again. So the simpler data types called scalars are integer, long. When the integer becomes really big, you cannot fit it in the integer. You generally should go for long, okay. Float, and then double. Double is 4 bytes decimal number. Float is 4 bytes decimal number, and double is 8 bytes, which means double can store a lot more, um, can store a bigger decimal number than the float. Then you have char array. Char array is nothing but a string, okay, and again char array doesn't have a size, okay. The way we define, when we define a column in SQL, we say varchar. Here it's char array. Here it's char array. It's an array of characters. All right. But note that in case of varchar, we define the size of the array. Here we are not defining the size of array. Srini's question is, Pig can access both HBase and HDFS. Yes. The output file part R does not have column names that we gave in step 1. Is it possible to have column names? Okay, so when we dump, it doesn't have the column name. So if you want to have column names, you may want to edit this file or append to it. Okay. All right, that was Rohit's question. I need to actually think about the answer. It's, yeah. So it doesn't have column names. So yes, we cannot have the column names just like that. And generally, when you do the analysis of the data, you do not store the column names into the file. Okay. Now, going ahead. So those were the simple data types called scalars. Sometimes your data is complex, and you cannot represent the data using simple scalar data types. For those cases, you can define your column as complex data type. While loading the data or while creating a data definition, you can say that my data is complex, such as map. And what is map? Map itself is a key value pair. Okay, so a collection of key value pair is map. All right. In case of a map, the key can be a character array. The name of the key can be a string, and the value can be anything. It could be scalar, it could be a complex data type. So so a field, in case of field or column, whatever you want to say, can be of complex data type. All right. And sometimes you would like to define your field as tuple. Tuple is nothing but an array of fields. Okay. Or you can think of tuple like a single row. A single row in a database is a tuple containing columns. All right. So, right. So a tuple is a fixed length ordered collection of scalars or complex data types, or you can say it's a it's a basically a row of a database table. All right. Now it can further contain the complex data type or the simple data type. Like you can see here, this is our tuple. First value of this tuple is a string, the second is a number, third is a decimal, and fourth is a map. Okay, that's our tuple. So we can say that, okay, this column is a tuple. This column contains tuple, or this column is basically a map. So we will see as we go further how do we load data into complex data types. All right. Now the third is the bag. Okay. So when a table or a collection of rows is called a bag. All right. A bag is an unordered collection of tuples. So whenever we are defining our data set, we generally define it as a bag. Okay, and this is the symbolic way we represent it with curly brackets. See that? So when we are loading data from a file and we are expecting it to be a bag, then it should have curly brackets. Similarly, if we are loading the data from a file and we are expecting it to be the map, then we can and if we want to load directly as a map, then that field field value has to be surrounded by square brackets. Okay, so a bag is a collection of tuples, and it's analogous to set of rows or data set. Now the important property of bag is, in case it doesn't fit into memory, it will spill over to the disk, and that's a very important property, which basically tells that bag can have a lot of data in it. Okay, while tuples or map should have small data in them. Okay, Harita's question is, should bag has the same data types? So good, very good question. Very good question, Harita. Thank you for asking this. Should have same tuple types. That's a good question. So by definition, the way we have studied in our SQL, if you must have read about tuple algebra. So in tuple algebra, a tuple is a relation, and the bag, I don't know what do we call it. Okay, so there, in case of relational databases, a bag is generally having all the tuples of the same data type. But in case of pig, the data types could be different. Okay, data types could be different, and you can process it accordingly. Okay, so pig as such would not enforce anything on you. There is it definitely it doesn't influence you, or it doesn't force you to have the same data type in same data type of tuples all across. Therefore, that's one reason why we say that Hadoop can handle or pig can handle the semi-structured data. That's why we say that a pig can handle semi-structured data. So it doesn't have to be. All right. All right. But while defining the bag, we define it as if the data type of the whole uh, table is going to be the same. Okay, while defining, but while loading, some of the records might fall out of the place, and those records will be handled separately. All right. Now Rohit's question is why tuple is called an ordered collection. So no, yeah, here, because when we want to access the individual value of the tuple, we can always confidently access it using the index. We can refer the fields by the position. Okay, here when we are referring the values in bag, we should not be accessing it with the index, because we do not always have the guarantee of a particular row being at the same place. Anand's question is whether bulk processing is possible using bag data type. Yes. All right. Most of the processing we will be doing on bag. All right. So those were the data types, and now let me just try to explain what does it mean by a schema. All right. So the first thing to understand is pig is not very particular about schema. Okay. So either you could tell upfront or you could just completely skip it. Okay, such as we are saying dividends equals to load this particular file as, then we are saying these are the name of the columns. Okay, we are saying exchange is character array, symbol is a character array, date is a character array, and dividend is a float. Okay, so as per this example you can see here we are telling upfront that these are the data types. Or okay, so we are saying in this particular statement the dividend is equals to load this particular file. Okay, so either we could have said this. Okay, either we could have completely skipped the defining the data types. Okay, or we could have even ignored these column data types. Okay, and pig will take the right guess whenever needed. All right, so pig will take the right guess whenever needed, so therefore it's not very particular about schemas. Okay, so schema data type, I mean the definition of the column could be scalar, like the way we have defined exchange is a character array, symbol is a character array, or it could be complex. Okay, for example we could say a particular column that this column is map. Okay, so you could either leave it as such, saying that okay this column is a, or you could go one step further and say that this column a is of data type called map, and then you could go one step further and also define the data type of the value. Okay, because key of a map is always a string, so you don't have to define that part. But when you're defining a column and you're trying to load the data, you can go one step further and say this map contains this kind of value. Here we are saying that a value is a tuple. Okay, We could also say instead of that, that it, or let's say X is the column name, and we could say the value is character array. Okay, or the way we have said, the value is a tuple here. All right. So that's how we can define the even the complex data type. All right. So here we are saying A is a tuple. We are saying A, either we could say that A just tuple, the way we have said character array, or we could go one step further and say this tuple has got these columns, and then otherwise we could go one step further and say that, okay, one particular column called A is a tuple which has column X and Y. X's data type is int and Y's data type is byte array. Alright? Alright. Now the third way to do it is using the defining a particular column as a bag. Now again, bag, either we could say simply that, hey, this particular column is a bag, meaning it will be an ordered collection of tuples. Okay, or we could go one step further and even tell that what kind of bag is it. Okay, so uh, okay, so Harita, now you can see that your regarding your question, in the second case, in the second case the data set has to adhere to this, while in this first case it doesn't have to adhere to, all the records of the bag does not have to adhere to a particular data definition. Okay, so in this bag the first collection, first tuple could be, could have 3 columns, and second could have 10 columns. It doesn't matter, but when we are defining this, we are saying explicitly that my bag contains tuples, or my bag is made up of these rows where each row has got this data type. Each row has got this data type, right? All right. So these data types could be casted from one type to another by affixing the data type within the bracket. Like if you want to convert this symbol into integer, you will put int in front of it. If it's not able to cast it, it will give an error to you. All right. Now, so that was about the data types in Pig. So what we saw just now is Pig is actually fairly flexible. It doesn't enforce you to define the data types upfront. So whether you are churning text or churning values, integers and floats, it's completely okay with it. All right. Now, the first statement of Pig. Till now, we were just discussing theory. So let's try to load one particular file. Okay. So if you go into H1, if you could see this in Hue. All right. You could see this in Hue. Ours is T7974, right? Okay. Now coming back to here. Sounds good to you? All right. So either we could simply load it saying div is just a data set. We are giving a name to this statement as div. So we could simply say div equals to load this, okay, and put a semicolon. All right, and then say dump. Okay, so it's basically dumping the whole file onto the screen. All right. All right, let's take a break for some time and then come back and carry on the discussion. All right, let's take a break for 10 minutes and come back. Hmm. So, hi, I'm back. Should we start now? I'm sorry for being a little late because one of the server had gone down, so I had to bring it up. Okay, Srini, you can try now. I think it should work now. Hi, should we start now? Is everyone back? Are you guys back? Should we start now? Awesome. Let's move. All right, so we were talking about loading the data, right? So either we could load it simply like saying divs could be any variable, it's your variable. It represents the data set, or it's basically a big bag of rows. All right, divs is basically a big bag. So it is equal to the load this. We are saying load one particular file, and by default it assumes that this data inside it is going to be in plain text, and it loads into the div by assuming the tab separation. If this data is tab separated, then it will get loaded. All right. As for different columns, if there is no tab in the input, there will be only a single column. All right. So by default, it just loads everything as a binary data, as in byte array. And at later point of time, whenever required, it does the what do you call automatic translation of data type. Say, for example, if you're computing sum and the data type is a string, it will try to convert that string into integer and then run the operations like sum. We will see that at a later point of time. But right now, what's important is that this is the statement which says that our data set is nothing but this particular load statement. Okay. Now, sometimes your data may not be tab separated. Therefore, you might have to use a syntax like this. Here we are saying my data is big storage and is comma separated. Okay, so it tries to split the data by comma and then load it. Please note that it does not adhere to any Microsoft CSV standards. Okay, so if the data contains comma, if the column value contains comma, it doesn't work. It doesn't work in those cases. In those cases, you will have to use some other method we will talk about later. So for time being, we can say that using big storage and specifying a particular separator is is basic way of loading data which is not tab separated. Okay. Now sometimes you are loading many files. You can simply say load nysc and asterisk. So it allows you to put the wildcard characters. All right. Now what if your data is in HBase? HBase is a database provided by Hadoop, which runs on top of Hadoop. So if your data is in HBase, you could load that using HBase storage. Okay. All right. Same, the statement which we have defined in the first line could be also written like this, where we are saying that my input has got four columns like name, ticker, data, and float, or my input is made up of bag, which is a tuple containing these four columns or four fields, and their data types is these. Okay. Now sometimes you might have to load data from the sources which is not default tab separated file. In those cases, you could use JSON loader the way we use H-based storage, pig storage, we are using JSON loader. For using JSON loader, we don't need an external library because it's part of pig's core libraries. Okay, and then load the data from JSON into pig. All right. Now, once you have loaded the dataset, you could do a couple of things such as explain dataset. Explain dataset explains what is going to happen. Okay, explain dataset explains what is going to happen when we run the dump command or when we run the store command. So also one very important aspect, the actual action happens only when we try to generate the output. Okay, this is called lazy evaluation. So the whole pig script, whenever we are executing statement one at a time, is not really doing anything. Is not really doing anything. It's just making a note of it. Just making a note of it. That's it. But the moment you try to store the data or print the output, if you want to store or print the output, only then it will start evaluating all of the data set on which the one which you are dumping or the one which you're storing depends. Okay, so for example, if we say things like, let me just launch pig. Okay, so here nothing much has happened. Okay, it just made note of it. Oh, divs means this file. If we do other operation, nothing much would happen. It will wait for us to say things like dump or store. All right. Now to see what is there inside divs, we could either use a command like describe divs. Okay, it says there is no structure defined, no schema defined for div. Or if we have said as x a comma b comma c and so on, and and yeah, in those cases if you say describe divs, it shows you that okay, divs is made up of 4 columns, and first column name is a, second is b, third is c and d, and by default it assumes their data types to be byte array. All right, now next step is that once we have loaded it, the other thing we could do is we could say explain divs. It will tell us the complete plan, as in what is going to happen when we run this, what is going to happen. So it shows that it's a map reduce plan, it's a store. Okay, all right, now you can see the new here, logical plan, physical plan, and as you go forward you will understand. Okay, it shows you that these are the fields getting loaded and so on. Okay, now that's about explaining a data set and describing the data set. All right, those who are going to use pig for a little longer time and their daily workflow involves pig, for them there are many syntax highlighting tools such as Eclipse. There is a plugin for Eclipse, there is a plugin for Emacs, TextMate, and Vim. You can use those highlighting tools. All right. So after load, the next statement is store or dump. If we say store, it will basically take a dataset, store it in the file system. And this file system is generally HDFS. If you are not running in a local mode. Okay, so you can do the same thing. We can say store. What was the data? This was our data set name. Store divs into my divs, and this will start the process of storing. This will start the process of storing divs. Now, most important thing you should know about store or dump is they not only generate the output, they are not only print the output either to standard output or the file system, but they start the whole process of execution. If you don't do store or dump, nothing is going to happen. Everything else is just a program which is waiting for getting executed. When we say a equals to load this, load that, or we do more operation on those data set, it is just a kind of a lip service. It doesn't really do something. It just makes a note of it. Okay, fine, you said it, I note it down. When we generate the output, then we'll think about it. Okay, and why does pig do it? So that it could do it batch wise. Okay, so MapReduce is a batch wise process. Running it statement by statement is very costly. Therefore, pig runs it only when you say dump or store. All right, does it make sense to you? Then dump, as we have already shown you, prints the values or prints the value of the data set to the screen. It's useful for debugging, and sometimes when you want to redirect the output of a program, you want to save somewhere, then you can use dump as well. All right, so that was about store and dump. Now, the next statement after load, store, dump, the next fourth statement, which is important, is for each. All right. So let's try to see if we can do. So we loaded the divs, okay, into and gave it a four column names, column name, ticker, or something. So divs is just another name. You could write your name. Okay, we could write KBD, and it's completely okay. All right. So now here please make a note of this statement. Here it says values equals to for each divs generate ticker comma value. So all we are doing is on a data set we are going from top to bottom, as in the first row to last row, and then only generate these two columns. So for each is more like select statement. If we were in databases, we could have said select ticker comma value from divs, right? So for each is nothing but the projection, projecting one data set onto another. Okay, so we are, instead of all the four columns, we are picking up only these two columns. Okay, now let's try to store it in something like values. Where here the first values is the name of this, and second one is the name of the file which is going to be generated. We could also say value underscore one. Okay, just because it could be anything. All right. So it's running and it's going to store the data there in this folder called values. Right. Now notice that when we said store, only then something happened. When we said for each, it didn't happen. Nothing happened. For each basically was noted, as in pig noted down that okay, you have tried to, you want to execute for each, but I'll execute it only when you say store or dump. These are very important points. So you can see that it's probably executing. Yes, it has stored our data in this particular folder. All right, so we can see. You can see that it has generated So we could also bring it here. All right. See that? So yeah, it has only picked up 2 columns out of 4 columns and stored it in HDFS. All right. So that was for each. All right. For each has more options to it. So sometimes you do not know the names of columns. In those cases, you could refer them based on their index. All right. Also, just like select, you cannot only say a comma b. You can also do mathematical operations. Here we are trying to subtract one value from another. So close minus open, that's what we are trying to generate. For each prices, generate close minus open. Okay, you could give it a name as well, this computed value. Sometimes you don't know the column name. In those cases, you could use $6 minus 3 kind of format. As in, we are saying, give me the seventh column. When we say $6 is seventh column because the numbering starts, the reference, the zero means one. Okay, $0 means first column, and therefore $6 means seventh column, and $3 means fourth column. Okay, so if we don't know the column names, if we have not given it, if we have not defined it, let's say we just executed this but we did not give the column names, in those cases we cannot use the first format because it doesn't know what is close and what is open. In those cases you have to use this kind of format. All right, sometimes you want to select a range of columns from a data set. You can do that by using generate dot dot open, a colon colon open. Okay, so what does it mean? What it means that all the columns beginning from the beginning of the data set till open, okay, from beginning till open is what gets selected. Okay, when you have to select ranges of columns, in those cases these kind of options are good. So when we say sometimes you want to just pick up columns starting at some point, ending at some point, you can do that using open dot dot close. Okay, a dot dot b, that kind of format. Sometimes all the columns after a particular column, in those cases we could say a dot dot. All right, whatever is the column name. Now you can see that we can do the mathematical operation. We can refer to each column by index instead of a name. We can also do the select a range of columns. Now this is something very similar to select statement. Yes, open dot dot close includes both open as well as close. Thank you, Anand, for that question. All right. So that was for each loop. Again, let's think about it. What's going inside when we are running a particular code? Okay. So my question is, if you have to do the for each, would you require any reducer? Yes. Will there be any reduce phase? Anyone? So let's have a look at what happened when we saved our data here. Okay. When we So you see this name. Can you see this name? What do you find different here? Part dash M dash 000. So in the previous example which we gave, do you see the difference here from the word count? In word count, it was R. Okay, meaning that the data has been saved from reducer phase, but here the data has been saved directly from the mappers. Therefore, you see M in the file name. So we have basically whenever the data gets saved directly from the mappers, its name is part dash M dash a number. Okay. So it did not go till the reduce phase, right? So most of you are correct. So it does not have any reducer side code because at the end of day, everything these all the script which we are writing, whenever we say dump or we say store, these scripts get converted into MapReduce and execute on the Hadoop. Okay, so So it this particular example will not have the MapReduce phase. Why? Because for each does not require MapReduce. Okay, why is it so? Because in for each, all we do is we go from one record to another till the end, doing the projection, as in modifying the presentation of data. Okay, make sense to you? Is everyone with me? Yeah. Now, the for each has more complex forms than we had. Let's take a look at this particular example, the baseball example. All right? The baseball example. All right? So let me get you the data. I'm not sure if the data is there. All right, let me try to get you the data. Just give me a second. And Hadoop fs minus ls. This particular file is in a different folder. I need to copy it. So Hadoop fs minus ls slash data. Okay. So inside pig, do I have this data? It's not. Okay. So I'll have to get you this data. So stay put and let me SSH. Okay. All right, let me just get you this. It's not there. Where did we keep it? So which folder are we talking about right now? All right, just give me a second. Let me try to figure it out. Sudo minus u, and I will say, what was that login name? All right. Yeah, here it is. Copy, not copy as in copy, it's cp. Hadoop, not this, sudo minus u, and then we are saying hdfs, hdfs, Hadoop, fs minus cp, cp slash tmp, baseball. Alright, now I think Hadoop fs minus ls data slash pick. Alright, good. Alright, the data we are talking about is, okay, okay. Alright, now we have, alright, now we have exercise. Alright, so what we are going to do here is we are going to look at this particular data set, data slash pig. This is the baseball data set. Alright, so what you see here is a complex data structure. So first column in this is the name of the player. Second column in this is the team, name of the team. Second, the traits. Third column is the traits. And the fourth column is a collection of records. Okay, the history of this particular player. Okay, please note the curly brackets. So here the way the data has been stored is, this is a bag of various values, and each tuple contains only one column. Okay, while the last column you see, this one is a map. Okay, when we talk about pig, the last column is the map. All right, and then we have to, let's say, pick up only, say, average. Okay, there will be batting average. So this is the only thing, let's say, we want to find out. How will we go about it? How will we use for each projection to just pick up this value from baseball? So this is a complex data structure, and we want to process it. All we want is the player name and the batting average. That's all. Okay, so how will we go about it? That's where for the complex data structure comes into play. So we are saying b-ball equals to load this, and the column names are these. here we are saying that the third column is a bag, okay, and we are not specifying what's the data type inside the bag. And then we are saying that bat is a map. Bat is a map, okay. So let's say we, okay. So we have loaded b ball, and we can say describe b ball. So it shows us the data type. And then we could say average equals to for each b ball, generate only the name and the batting average. Alright, now we can see that if we say jump, if we say dump here, it will print all of the data. Okay, so you can see that it has printed the name of the player and the batting average. Okay, let's have a look at their names in the actual data set. So here when we go to the last page, let's say page number 58. So you can see Joel Sumaya. For Joel Sumaya, there is no batting average. While for Bon Jobrist, the batting average, where is the batting average in this? Games, hit by pitches, on base percentage. Okay, yeah. Okay, then here batting average is 0.26. And what did we get? 0.26. Correct? So basically, this is how you do the projections on complex data structure. Alright, did it make sense to you? So we were able to successfully pick up a one particular value out of the hash map. Alright, so we can do the projections on the complex data type in the following manner. If you are just trying to pick up one column or two columns out of one tuple, you can do that easily. You could simply say t dot x. Whatever is the name you have given to the tuple, we can use that to refer to a tuple. So here we are saying our input is made up of record, which is a tuple, and this tuple contains two columns. And here when we are saying for each a generates t dot x, meaning out of this tuple just pick up the first column, and it's the first column again repeated because $0 means first column. All right, now the bag projection. All right, now the bag projection can be done in the similar manner. If we just want to pick up the first column out of this bag, then it will give us, we can simply say b dot x. Also, if you have many columns to pick, instead of saying b dot x comma b dot y, you could also say b dot x comma y. All right, so that's how you do the projections on the complex data type. So Srini's question is, for each is an existing function. Yes, that's right. All right. Now you could do a complex computation, and and when you do the computation, you could give it a new name. For example, we are saying for each divs generate divs dividend dividend into 1000. Okay, and then give it a name. Okay, or you may choose not to give a name. Alright, so these are the things you should keep in mind while doing the for each. Alright, now we are moving one step ahead. So similar to SQL, we have group by. Okay, the only thing is, unlike SQL, whenever you are defining a group by, you have to mandatorily define an aggregation. Here, that's not the case. You do one step at a time. You first do the group by, and then you do the after doing the group by, in the next statement you could do the for each and do whatever you want to each group. Okay, so group by is purely a grouping function. It just groups the values together on a certain basis. Okay, it just groups the values on a certain basis. So you can see here that all the people of the same age have been grouped together when we say b equals to group a by age, group a by age. And what is age here? Age is the second column, which is 18. So for John, the age is 18. For Mary, it's 19. For Bill, it's 20. And for Joe, it's 18. Now, the important aspect here is that all the records whose age is similar, they have been brought together, and this new group is basically a bag of tuples. All right. So these bag of tuples have come together. Okay. So sorry, these tuples have come together to form the bag. Okay. So the key is age. All right. So so new bag has been created where each record of the bag is these records, and the names of various columns are as follows. In newly generated dataset, the first dataset is the same name as the actual the first dataset's name becomes first value's name on which we are grouping the data becomes the group. Instead of age, its name is group. Okay, and the group, the after this all the dataset which has recently formed containing all the tuples, that the name of that one is A as in the original A. Okay, so this is the name of this column is group, and the name of this column is A. All right, so this is how the grouping happens. It groups the data on some criteria. All right, so please note that it has not done any aggregation. It has just brought the record together. Also, we could group on multiple columns. Okay, we could group on multiple columns. So all distinct values of those columns and their permutation will become the group key, and the values will be a bag. All right, is group by clear to all? Yes. Great. All right, so the most important aspect to understand about group by is the data definition. Here, whatever tuples you give here, they will get grouped by that particular parameter which we are talking, and then all those records will come together for that particular key. Okay, so after group by you will see flatten. Okay, so flatten is just opposite of group. It is just opposite of group. For example, let's say you are given a data set containing Sandeep and then curly bracket C and C++, meaning it's a bag of tuples. And after loading this data, what you want to do is, after loading this data, you want to ungroup it. You want to you want to display the values like Sandeep C, Sandeep C++, Arun Shell, Arun C, and C Money is Java, C Money C++, C Money Lisp. Now we could we could ungroup it, we could flatten it, and that's where I mean the name flatten is very apt for what it is doing. It's ungrouping the values to their original form. So you can see that this will happen. Now one common question arises here: why would I want to do this? Why would I want to ungroup it? Okay, so answer is very simple. Let's say right now your data in this input, you can see that here here the data is grouped by the name of people. Let's say you are trying to find out the statistics like how many people are using C and how many people are using C++. In those cases, you will have to first ungroup it and then group by the language. Right now, it's grouped by the name of the person. If you want to group it by the name of the language, then you'll have to first flatten it and then group it by that language, and then after grouping you can utilize for each to apply on the bag. So let's say after group by we got the bag here and you want to shrink it, you want to do a shrink. In those cases you have to do the for each on top of b, and then after for each you have to apply the count function on the second column. Okay. All right. So sometimes we do not want all the records in the output. That's where the filter command comes into play. So we can say divs equals to load data. And then after that, we could say filter divs by a condition. Okay. And the condition would include, the condition could be something like symbol, name of the column, and then operator, and then operand. Okay, or it could have and an or, like this. So you can see, so here we are saying filter divs by this condition. And what does this condition say? Symbol matches cm dot star. What does it mean? Anyone? What does this regular expression means? Yes, Peter, Harita, Rohit, Shini, Xiao. Yeah, what does this wildcard character means? We are saying cm dot star. Which symbols will it match with? Peter says unlimited number of any type. Okay, dot star will match with unlimited number of any type. Good. Overall, this string will match. Rohit says it will return all the records with the symbol starting with CM. Harita says any symbol starting with symbol. Any symbol with CM and any characters. Harita, will it match? Will it match ACM? Okay, good, good. So, Peter, it will not be CM dot one, CM dot two, CM dot three, and so on. It will be CM1, CM2, CM3, and so on. Okay. So when we say dot, so I think most of you have not finished the first regular expression session. If you have not, please go through it. It is going to be quite useful to you. Okay. So there is this regular expression session. It just takes 20 minutes to finish it off. All right. So go through it. So here it means dot means any character and asterisk means zero or more of the preceding character, which is dot. Okay, that means anything here. Okay, now you could do the negation of the condition saying filter divs by not. Okay, it'll completely change the meaning, it will just reverse the meaning of a particular condition. Sometimes you can put and an or in this following form saying dividends greater than zero point 0.1 and dividend less than 0.12. Okay, and here it says that or condition here. So let's try to execute it if we can. All right, now if you see here and we say result, also please note that we are comparing with the number, and this dividend when we loaded is a float. Okay, here it's good, here it's good, there's nothing much. Okay, Harita's question is that I do not see Python session in my course list. Actually, the video that has come out of the Python session is pretty bad, and that's why I've been avoiding it. Let me see if I can get it refined. Although one Python course is going to start from Monday. Okay, if you want to join that, you can enroll for it. Okay. Anyway, I'll have a look at if I could refine my previous video recording. Okay. So that was our result. Okay, now you can see that clearly. Okay, so you'll have to put brackets in order to enforce it. Okay, so it's showing that either the value is this or it goes beyond the beyond 2.5, beyond zero point 0.4. All right. Right, so you could apply these conditions on the data set. Only those records which pass this condition will be put in the result. Now again, if you think about filter, will there be any reducer generated? Anyone? If you have to do the same thing what this command is doing, will you require a reducer? Anyone? Will there be any reducer generated for the following code? Think about it. Think about it. It's just filter. We are taking the data input, going by record, and removing those records which do not meet our criteria. Or we just keep those records which meet our criteria. Alright, good. It will be no. Yes, there will be no reducer generated for a filter command. Alright, sometimes you have to order your data by a particular column or a set of columns. In those cases, you could use order by. Using order by, you can order or you can sort your data by a particular column or by multiple columns. For example, here we are saying for this is my data, and here we are saying order this dividends by symbol and then by dividends, and that too descending. Okay, so that's how it works. All right. Now, if you want to just compute the distinct of the values, you can simply say distinct and give the name of the dataset. It will find the distinct tuples in the dataset. Anyone? Will it generate any reducer side code? Anybody? Yes, that is correct. Yes, because because when we have distinct can only be done once we sort the data. Otherwise, it will be very inefficient. On a big data, you cannot compute distinct without sorting. You cannot just load the data into the memory and iterate because it will be too time consuming and very intensive. Sounds good? Alright, now comes the join. When you have two big data sets and you want to join them on a certain criteria, joining the two dataset means bringing those records together whose key matches. Okay, that's what join is all about. When we want to bring, as in, if first record has 3 columns and second record has 4 columns, the resulting column resulting row will have the columns from both the sides. Okay, so that's what is a join. Okay, so for example, we are joining NYSE daily and NYSE dividends. Okay, and if you're joining by column called symbol, so all those records from dividend daily and NYSE daily and NYSE dividends, all those records whose symbols are matching, they will come together. Okay, so here we are saying take symbol all the values from symbol column in this table and all the values of symbol 1 column in this table and bring all those records together for which the symbols match. Okay, let's try to do it. Okay, let's try to do it. And when we say dump joined, So what does it say? It says that the file is not found. Okay, that's correct. That's correct because it's not in this folder. So we'll have to put in front of this, we'll have to put data pick, right? Okay. Okay, now we can dump JND and you'll get an idea. Just a second. Again, the input path does not exist. Why? ls/data. So yeah, it is in this folder itself. It's not inside pig. All right, let's try to do this. Okay, now when we say dump JND, now this time it's happening. All right, any questions at this point? Okay, so it's trying to execute. All right, it's trying to execute. You can see that now. The important thing which I wanted to show you is the columns, the resulting columns of this are so many. Okay, while if you go into this folder, so we have NYSE daily. Okay, so the important part I wanted to show you is how does it look like after joining. Okay, so you can see that the data from both the sides get joined like this. All right, so all the columns from these two tables have become one. Sounds good to you? Okay, so there is a question from Anand. How can we validate whether the results are proper or it's giving Cartesian join? So yeah, so it's kind of a Cartesian join. Okay, Cartesian join on these two tables. Okay, so you can validate it by using some other tool. Okay. The other thing you could do is you could try group by and then find the unique records. All right. So that was a quick way of displaying that it's working. All right. So this was a join on one particular column. Here we are just joining on symbol. Symbol from here, symbol 1 from here, we are joining together. And all those records whose symbols are matching, we're bringing those records into a single record. Their columns get appended. Their columns become one. All right. Now sometimes you have to join on the basis of multiple columns values. In those cases, you could use a format like this. Here we are saying join daily and divs where exchange and symbol of daily is equal to exchange and symbol of divs. Okay, you can see that. Alright. Sometimes you have to do the self join. Now self join is little awkward here. You cannot join a table with itself. Therefore, you have to load a data set twice. So you can see that we are loading NYSE dividends first into divs 1, then into divs 2. Okay? And then joining divs 1 and divs 2 together. Alright? Now, there are minor differences from RDBMS here. There are minor differences. First, join should always have a column. Join should always be on one column. Like the way it used to be in RDBMS, where if you don't specify the column, it will basically do the Cartesian product. Okay? If you have tried, just do select star from A comma B. All rows of A will get mixed with all rows of B. Okay? That's what it used to be in our SQL. Here you must have at least one column as a part of join. You cannot have a join without a column. Also, you cannot have conditions as part of join. You can only have columns. Okay? You can only have name of the columns at the basis for joining the two data set. Can anybody help me understand why are there such restrictions? You can figure it out if you think about what it does inside, to do the joining. You remember our problem, fifth problem of vote count. You remember our fifth problem of vote count. How did we do the join? If you think about it, you will get the answer. Why there has to be a column for joining? Why can't there be a condition for joining? All right. Another question which from Rohit is, what is double colon here? In case when you have joined the two tables, the new name of columns are little different. I'll show you how they look. Okay, let's have what we did just now. So let me show you what do we mean. Thank you for asking this question, Rohit. Good question. So we were joining two data sets, isn't it? Okay, let me just have a look. Yeah. So we were joining two data sets, daily and divs. Describe daily and describe divs. Okay, so daily has columns like exchange, symbol, date, open, high, low, close, volume, and this. Okay, now the similar columns are there in divs as well. Divs has this, and this. Okay, so now if you say describe joined, all right. Now when you join two tables, when you do join two tables, the resulting column names change a bit. You see, they are prefixed by the name of the dataset. So you can see that the way the column names have got prefixed with the with this. All right, you can see that. So basically, it is just for clear resolution of the name that while joining the two dataset, it prefixes the columns with their respective dataset names. Make sense, Rohit? Harita's question is, so when prefixing which dataset, will it use, okay, so when prefixing which dataset will it use if the column exists in two dataset? So that's why if the column exists in both the dataset, then also the name of the column, the newly generated name of the column, which is composition of first table and second table separated by double colon, will be unique. Okay, will be unique. Make sense now, Harita? All right. So here, when we are filtering the data, like here, you see that whenever we are filtering the data after joining, what happens is the name of the columns change. Okay, and then we cannot refer to this column exchange just like that. We'll have to refer to this column as divs colon exchange. Okay, that would not cause any confusion. But in the JNA, it uses the name as daily. Yes, that's what it is. I didn't get the question, so let me try to understand again. So we had daily, okay? Daily has got a name called exchange, while we have another dataset called divs, which has got name called exchange. Then we have got joined J and E, which is formed by joining the two tables based on certain criteria. Okay, so and therefore the result of joining is the name of the columns will be fully qualified. Okay, so if you are running something on JND, you will have to say filter JND by, let's say, daily exchange equals to NYSE. Okay, Anand's suggestion is that select star from daily A divs B, where A dot exchange equals to B dot exchange. Correct. All right. Good. So that was how we do the joins. I hope it's clear to everyone. So the names that get generated are of this form. Okay. All right. Now moving on. So similar to SQL, we have different kind of joins. Similar to SQL, we have different kind of joins. So by default, we call it, by default, the join which we have, it's called inner join, where we don't provide any left or right. So you can see that when we are joining A with B on ID, the resulting is one Sandeep, one Giri, because two Ryan, two is not there on the B and three is not there in the one. Okay, so this is how you can join the two records. This is called inner join. All right. Now there's something called left outer join. There are inner joins, then there are outer joins. Outer joins make sure that even if the records from one side is not found in the other, the record still goes in the output. That is the outer join. So outer join could be of two types: left outer join or right outer join. Left outer join means the values from the left hand side would inevitably go in the output. Okay, so the values from left hand side, which is here A, so one Sandeep and two Ryan will go into output even if there is no corresponding value on the right hand side. Okay, so that's left outer join, and then you have right outer join. In case of right outer join, values from the right hand side will go into the output whether there is a corresponding value on the left or not. Okay, so for example, we have got one Giri, three Saha in the output, while for one Giri there is one Sandeep, but for three Saha there is nothing. Okay, so that's the use of the right outer join. Right outer join or left outer join could be used to do the subset, to do the intersection, and many more. Okay, all right, so that was one. Anyone? Quickly, last question of the day. So join A by ID, right, and then comma, B by ID, dump arrow. What will be the result? Peter says match on Ryan and Giri and then Saha. But yeah, this is little teaser, little teaser. Think about it. Anyone? Pankaj says it'll be 4 Giri and 3 Saha. Interesting. So it'll be, yes, yes. All right. Now there is something called full join. Thank you, Pankaj. Good. Okay. So there is something called full join. Full join is what? A composition of left and right. Okay, so left, right, and inner join combined together is full join. Okay, you see that? So for one Sandeep, there is a value called one Giri because we are joining on ID. Therefore, one row has one row has columns from both the sides. While for two Ryan, there is nothing on the right hand side. Therefore, it is like this. For three Saha, there is no corresponding value on the left hand side. Therefore, it is like this. Right? Now, question to all of you is question to all of you is when we joined A by ID and B by ID, that is inner join, there were total number of N1 records in the output. When we joined A by ID and B by ID and it was a left join, there were N2 records, and for right join there were N3 records. So how many joins will be there for the full join? Anybody? Yes, that's correct, Rohit. Anybody else? Okay, that's correct, Peter. Peter, good. Okay, Xiao, do you want to subtract anything? All right, great, great. That's correct. It will be. So when we are joining full, it means records from both the sides, which is N1, which is a- N1, and then records from left join, okay, minus the common because left join contains common as well as only from left hand side. Similarly, right join contains common as well as the right hand side record. Therefore, we are subtracting n1 from both the sides, and the result is n2 plus n3 minus n1. All right? Yes, that's correct, Shio. All right. Great, great. So that's pretty much for today. We are already running by 6 minutes late because we started a bit late and there was a break in the between. All right. See you tomorrow at the same time. Bye bye. Have a great day.